Now we want to look at, given certain conditions, what would a shape of our graph look, what would our curve look like? So again, similar to what we did early on when we did introduction to calculus and graphed a lot of functions and looked at the sign of the graph and sign of the gradient, and then worried more about what the sign was rather than what the values of the curve were doing. So in this case, if we remember, our first derivative greater than 0 means our curve is rising. So we need to remember all these situations. Our first derivative, so our gradient is less than 0, our curve's falling. And when our derivative is equal to 0, it's stationary. So we have that stationary point there at some point. Now, what about if our second derivative is greater than 0? Well, if it's greater than 0, so it was concave up. So our curve there should have a positive second derivative at each point. Here, where our second derivative is less than 0, our curve will be concave down. So we know that that's what we're going to get. And if our second derivative is equal to 0, we know we have a point of inflection where our gradient, our concavity changes, goes from concave down to concave up, or vice versa. So that's what we're looking at when what our curves would start to look like if our second derivative is either greater than 0, less than 0, or equal to 0. So what happens when we combine all these situations? So a second derivative that's greater than 0 and our first derivative is greater than 0, the curve's rising and concave up. So all our curves here should be rising because our first derivative is greater than 0, so should we have a positive gradient. So in this one where we've got our second derivative less than 0, our curve's rising but it's concave down. So this one rises and it starts to rise quicker, but this one's still rising but it slows up. This is where we've done a lot of work with curves in year 9 and 10 to play around and talk about our curves in that way. And this one it's still rising, but it changes its concavity. Notice it's going from concave up to concave down. So, but it's rising the whole way through. This time we've got the first derivative is less than 0, so our curves should be falling. Our values, y values are getting smaller each time. But if we've got a gradient that's, our second derivative is greater than 0, it'll be concave up. So the curve's falling, but it's starting to ease off a bit. So notice it starts rapidly, but then eases off with how it's falling. This time, it's still falling, but we want our second derivative less than 0, which means it's concave down, which means it comes from a place where it is not so steep, but then gets steeper. So it decreases, and it decreases at an increasing rate as such, because it starts to drop much quicker. And here, the first derivative is always 0. Greater less than 0, but we get a change in concavity from concave down to concave up there. So all these ones where we've got stationary points is concave up and stationary. Okay, our first derivative is equal to 0, and our second derivative is greater than 0. So we'd normally call that a maximum turning point, because that's where, a minimum turning point, because that's where it comes down, turns, and goes back up. So a minimum turning point has a second derivative that's positive, but a first derivative is equal to 0. A maximum turning point, this time we'll have a first derivative equal to 0, but the second derivative less than 0. So notice it rises, stops, and falls. So it's concave down the whole way there. And this horizontal point of inflection we talked about in some of the other videos is one where the gradient doesn't change, but it becomes stationary there. So they're all the three situations where you've got the different signs of the gradients and the different signs of the second derivative. So the concavity talks about our concavity, talks about our gradient, and what happens to our curves when we put those all together.